Hello and welcome back to this episode on recreating Baldur's Gate 3's camera inside Unreal Engine. In previous episodes, we managed to get the camera moving about, rotating, zooming in and out along a spline, all that fun stuff. We can lock it to the character, and yeah, so that is all good. We are going to move on and we're going to try and implement the top-down camera, or the orthographic camera. It's not technically orthographic, that's a very specific type of projection, but it's still it's a useful way of describing the kind of thing we're looking for here. And as well as that, we're going to make sure that the camera doesn't clip through the landscape like this. As you can currently see, our camera stays at a very specific Z value in terms of its height, and any movement will just kind of go along that plane. We're going to make sure that it kind of follows the landscape a bit better. Now, there is a caveat to that. If you're playing Baldur's Gate 3, you might have noticed that the camera never actually gets lower than the player character itself. This is something I found very frustrating, but I think there's a few design reasons behind that I'll kind of get into as we're developing it. But yeah, for the time being, let's try and make the orthographic camera. So, let's load up the camera blueprint first of all. And we already have a spline for the perspective camera. We're going to want to do the same here with the orthographic camera. So first of all, we're just going to rename the perspective spline so that we can differentiate a bit better. Add another spline in and call this the orthographic spline. Now, it automatically attached to this perspective spline because we had that selected, but you can make sure it's attached to the scenery just by dragging and dropping and selecting attach. So there we have another spline ready for the orthographic view mode. Now we just need to set it up. Now, we're going to cheat a little bit. The idea of the orthographic, the top-down view mode, is that it's directly above the character. However, because it's Unreal, it doesn't really like having cameras that are looking directly downwards or directly upwards, as it kind of messes up the rotation of the camera. So we're going to cheat a little bit by having it slightly slanted, although it's very hard to tell the difference. And it should look pretty good without trying to get into quaternions or any of that fun stuff. So we want to replicate what we've done with the perspective spline. We want to make sure that the top input key is 0 and the one at the bottom is 1. This is just to make sure that the zoom percentage is the same for both cameras. So we can grab our perspective spline. Sorry, our orthographic spline. It's not grabbing it at all. There we go. And we're going to drag this up from the camera, or up from the center, and we're actually going to put it back to, let's say, minus 20 on the X value. Now we're going to grab the last point there, and we're going to drag that down so it's perpendicular or horizontal. No, other word, vertical. I'm going to make sure it's vertical and pointing down from the camera. We're actually going to line this up a bit more with the center, so we're going to probably put that to 10, whereas this is at minus 20. We can compile and save that now. And just make sure these are the same. Cool. Now, what we want to do is we want to add a variable for if it's orthographic currently or not. So we're going to call this B orthographic. And we want to be able to toggle the camera on and off between these two modes. So we're going to make another function called toggle orthographic camera. And this is going to be a flip-flop basically, although we're going to set it up with a branch. And what we're going to do is when it is orthographic, we set... Actually, probably don't need to do that. We can probably just do this. Get a not boolean in. And set orthographic to whatever it's not. So we always get the other value. And compile and save. And what else do we need? Set camera transform along spline is a function we did in a previous episode, and we're actually going to need to change this logic slightly to accompany for the new spline. So let's move this over to the side to get a bit more room. Tidy it up a little bit as well. I think this is a bit messy. And what we want to do is we want to edit the input to the getLocationAtTime function. So we can drag back from, I'm going to give a bit more space by dragging that details panel back. And I'm going to drag out from target, and I'm going to do select. And this is going to give us a few options now for the input as to which spline we are referencing. So we're going to get the value of B orthographic, plug that into the wildcard index slot, and you'll notice that the two values now become false and true. So if it's orthographic, we want to grab the orthographic spline. And if it's false, we want to grab the perspective spline. So this is automatically switching between these two splines for us. Now what we also want to do is in the toggle orthographic camera, we want to call that set camera transform along spline once again. And we can plug in zoom %. And the reason why we want to do this is because when we press this button, we want it to switch automatically and not wait for something else to trigger that switch. So if we compile and save that now, if we hit play, we should be able to hit O and switch between the cameras. We are not able to. Why is that? Have we got that set up correctly? No, of course not. We haven't set that up in the controller. So let's grab the controller. Game, BG3 player controller. And we want to hook that action up to switch camera. So as we've been doing with every other thing here, we're going to get a validated get check for the camera. And off of that, we're going to toggle orthographic camera. Compile and save. And let's see if that works now. Awesome. You can see it's kind of jittering about. That's something we're going to need to do on the input action, but it is nicely switching between the two view modes. Look at that. So let's fix up that jittering. What you're seeing here is the action is being triggered multiple times, and we can see that if we debug in. If I hit play and then make sure we can see the player controller, I will make sure we are debugging the player controller. And can I move this down to the side a little bit? If I hit O, you'll notice it's triggering, but if I hold down O, you'll notice that it just sort of keeps triggering. So it's triggering every frame. Obviously not ideal. We want this to trigger once when it's pressed. So how do we change that? We need to edit the input action for the switch camera. If we load up IA switch camera, we can see that the trigger is set to nothing. There's no array element here. So what we can do is change this to be on pressed. So it only triggers once when it is pressed. And if we try that now, if I press O, even if I hold it in, you'll notice that automatically we have no jittering and it's much smoother. So that is great. That is the perspective camera pretty much done. Now we might want to edit how far away from the character it is, but that is pretty much just a case of dragging the spline point further away. So the next thing we're going to move on to is setting the camera's height when you're flying around the level. Now, what do I mean by that? We want the camera to kind of follow the contours of the landscape as we're flying around. You might notice when we fly around right now, if we try and go uphill, it's going to go right through the ground and we're going to be seeing everything under it. So we're going to be solving that with a line trace and the camera. And what you might notice is there is a caveat there. I did mention it earlier, is that in Baldur's Gate, the camera will never go below the character's height. So like if you were to fly over a ground of lower height, your camera would kind of stay at the same level as the character. Now, I mentioned a few design reasons why I think that is earlier on. I think generally the main thing is that the developers never wanted it to be difficult to find your character again. And if you were able to get, low down, if I depossess here and kind of start flying around, now instead of 2 planes to worry about in terms of finding your character, now you have to worry about looking up and around as well. So I think that's just speculation, really. I don't have the exact answer for that, but yeah, we're going to replicate how it is anyway and get started. So let's open up the camera again. Coming back from the future here to say I forgot to make the camera height variable on the tutorial. So just coming back to make sure you have a float variable called camera height made before we continue. And the first thing that we're going to want to do is make a new function. We're going to call this set camera height. And the first thing in this function is we're going to get the player's location and set that set the character's z value as the desired height for our camera. So to do that, we'll get the player character, drag out from that, get actor location, and we're going to split the struct pin because we don't care about the x and y values, we only care about the z, and we're going to promote this. If you drag it out, we're going to promote it to a local variable. Now, the reason why we're using a local variable rather than a standard variable is generally when you're working with functions, and just it's good code practice to always keep your variables as low a scope as possible. So a local variable just means that it only exists within the context. What am I saying? Within the context of this function. And it means that you can't edit it from elsewhere. It's not referenced elsewhere. It's only used in this function. And that's useful for us. So let's call this one desired height. So we are getting the player's character location, and we're setting that as the desired height. The next thing we want to do is we want to line trace. If you drag out and do line trace, we'll do by channel for now. We might change it to objects later. And where do we want to line trace from? Well, we want to get the actor location of the camera, first of all. So we'll do get actor location. And the start and end point are going to be above the camera and just below the camera. What we're trying to do here is we are checking if, when you're flying around, if you hit any environment or any obstacle that we want to go over, then we kind of like leapfrog over it, basically. So to do that, we're going to do the same thing as the get player character. We're going to break this struct pin into its x and y coordinates because we're going to want a separate value for the z. Now, what that means for the line trace is we need to make a vector for both the start and end point here. Vector, copy and paste that for the end. Trace channel will change to camera for the time being. We might change all of this later on, but this is what we'll stick with for now. And actors to ignore. This is kind of why I think we might want to use line trace by objects, but we'll just set this up with our character for now. So we'll make array, and the only thing in this array is going to be our player character, because we don't really care about collisions with it. So there's that. Now, we need to actually plug in some values for the start and end point. So what do we want? Well, the x and y coordinates we want to plug straight into both of the start and end points because we're always checking the spot where the camera is. It's only the z value we're line tracing on. So we've got that. And what do we want? We want to get the desired height, which is the player's location, or the player's height. And what we want to do is for the start point, we're going to add kind of an arbitrary value here. We're going to go 2,000 units above the character is where or above the camera, sorry, is where we are starting the trace. We can adjust that value later, but we're plugging that into the Z. And what about for the ground, for the end value? Well, because we can possess different characters, what tends to happen, so what am I saying here? The pivot point for the characters tends to be in the middle of the character. If I can show you here, I can describe it a bit better. If we load up the player character, you'll notice that the midpoint is, maybe I'll drag him into the world. You'll notice when we drag him into the world, the pivot point is in the center of the character. If I can zoom in properly. So what we want to do instead is we want to check, instead of this is the desired height, we want to check the line trace from the bottom of the character. And to do that, we can adjust the location of the desired height by getting the scaled half height of the player capsule. So if we drag out from player character, we can do get half height, and we'll do the get scaled capsule half height capsule component. And we will take the desired height and subtract that half height. So we're getting the bottom of the character rather than the middle of the character for the line trace, and plug that into the Z. So if we visualize this now, we can draw a debug type for one frame for now. This isn't going to do anything, it's just going to show us the trace if we plug it into the event tick. Actually, we'll set up some logic in the event tick here to get started as well, so we can show it properly. So if it's locked to the camera, if the camera is locked to the character, we don't care about this trace because it's always going to be at the same level. If it's not, however, we want to set the camera height. And then from there, we want to set the actor location. So we're going to copy and paste the set actor location node from up there, plug that in, and kind of the same thing we did in the line trace. We're going to make a vector for the new location. Make vector. Break this. Plug that in, and we will be adjusting the Z later on, but I'm just going to plug that in for now so I can show the line trace. So if we hit play and unhook from the character, I seem to have lost the ability to move the character because we are setting the location. That is obviously not what we want here. So for showcasing, we'll delete that, but we'll keep the set camera height in the event tick. If I hit play, yeah, we can move about again. And you can see the line trace now, if I depossess, is going from way up there down to the height of the character. I'll show you the height of the character if I move out this way. Oh, there's the one we brought in. I'll delete him in a second. So you can see that it kind of ends at the height of the player character. If we zoom down a bit, that's kind of where it lines up. If we possess again, we can move around, and you'll notice when we collide with the landscape, it's going to give us a little hit marker. And that's what we're going to use to start adjusting the height of this sphere, of the whole camera. So let's bring this back. In set camera height, what do we want to do? Well, first of all, we want to check if we actually hit anything with the line trace. So we will get the return value of the trace and get a branch. And if it didn't hit anything, then we want to set the camera height. Oh, whoops. Set the camera height to be the desired height, just at the same level as the character. So we can go to the local variables tab down here, drag that in. And what we'll do, just for simplicity's sake, we might not use it for anything specific, but it's always nice to have a return value for stuff like this. We can add a return node and just plug in the camera height to the return node, meaning that if we go to the event graph now, you'll notice that the set camera height has an output. We'll rename that to camera height though. Cool. Compile and save. And now if we did hit something, what do we want to do? Well, the first thing we need to check is where exactly on the world it hit. So if we break the hit result, we can get the location. And we will break this vector once again, as usual, and just collapse that down so we don't need any of that other information. And we want to add, what do we want to add? We want to get the height of the character, or the half point of the character again. So if we copy and paste this, which is the capsule half height logic, we can add the Z value of the hit location to half the character's height. I'm hitting Q there to straighten up those nodes, by the way, which is a quick shortcut I found out very recently, and it would have been nice to know 9 years ago, but it's never too late to learn new stuff. And we're going to do the same thing with the set the camera height. So set camera height off of true. And what we're actually going to do is we're going to just hook that up to the same return node. You can make another return node if you want. There's not really any downside to doing that here. But yeah, we'll do that. We will make sure it's all on the same side because I hate crossed wires. Again, hitting Q to straighten them up pretty quickly. And move that across so it's not as ugly. That's still pretty ugly. That'll do. And then in the return node, we still want to hook up the camera height, so we'll just drag that into the return value. Cool, compile and save, and that should be our logic for controlling how the camera moves around. Now there is a caveat to this. You'll notice when we hit play, and if I move around so we get that line trace again, if the world does go above this line trace, what might happen is it'll snap back down to the same level as the character as it's no longer hitting anything. If I have a big hill somewhere here that I can test this with, like I'll try around here. So I will move the player start point. I'll actually delete that character so we don't get confused. And move the start all the way over. Keep going. And we'll start about there. You'll notice as I fly up this mountain, that hit marker is going up. But then if we get too far in, still going. If we get too far in, you'll notice that line goes red. And it means we're not hitting anything. Meaning that that would snap down to this level and we'd be kind of inside the landscape, which isn't ideal. So I think how Baldur's Gate usually handles this is it's very particular with its height of its landscape. And it does have some logic for controlling collisions. So, you know, if you try and fly too far outside of the bounds of a map, it will stop the camera. We're not getting into that too much this episode. Or we might not do it this series even. It's not as important for the system. But yeah, that's just something to keep in mind. So now let's actually hook up the logic so the camera takes that into consideration. So event graph. What we want to do is, let's see. We want to... We don't care about the player location for if it's not hooked up. What we do care about is the current actor location of the camera, and we want to plug into Z the new camera height variable. Or if you wanted to do another way, you know, you could hook up the return value as that's just returning the same thing, but we'll do it like that. If we compile and save now, let's see. Awesome. So now you'll see that the camera is actually going up and over terrain. It does have the issue, if it's too steep, you might get issues like this where you can see inside, but you can kind of avoid that with good level design. And if we wanted to get further, we could add some logic for collision and stopping it doing that. You know, we could add another line trace onto the camera component itself rather than the camera actor, so that if the camera hits anything, then we'd, you know, pitch it upwards or something like that. But that's that. Awesome. The last thing I'm going to do real quick is fix up something I found in the movement that we did wrong in a previous episode, which was camera speed is currently not dependent, or is currently dependent on frame rate. And you'll notice that currently we're running at 45 frames a second and moves at this speed. If we limit the frame rate, so we'll do T max FPS and we'll do like 5 frames a second. Watch that frame rate plummet. And if we try and move around now, look how slow we're going. So what we forgot to do is take into consideration delta time, which we will do real quick. I will actually just T.max FPS and we'll just stick that up to back, I don't know, 120. So in the move camera logic, what we want to do for the movement speed stuff is we want to add another pin and make that delta seconds. So we'll make that a float again. Both of them floats. Drag out and do get world delta seconds. Now we will, in a later episode, it might actually be next episode, start adding some more logic to the movement. So adding bounds to how far the camera can get out. So we might be rearranging this, but that's just a caveat to keep in mind for movement speed. We could do that as well for rotation and zoom, but I think those are less important. You'll notice straight away as soon as we do that, the speed plummets because it's multiplying by a very small value. So it does mean we need to put the movement speed up to from 10 to like 500. We can compile that and let's see how it goes. Yeah, that's much better. Yeah, so that's that. I hope you learned a little something here, and come back next time where we will be adjusting the movement system to account for bounds and various other little polish things that Baldur's Gate does with its camera. Cool, I'll see you there.